right. So this is technically for last week, right?
Yep. Last week.
All right. I kind of hated last week, I'll be honest. I miss my derivatives. I do. I'm not even kidding you, man. I despise whatever we're doing right now.
I agree.
You do something. I'm trying to figure out what happened to my computer. It doesn't want to run the internet, right? So it's giving me these pop-ups and stuff. Let me pull up the homework real quick. Was there anything that was really difficult for you or I don't know, anything you want to discuss or whatever?
Right. Not too terribly, I guess.
Huh?
It wasn't too terribly difficult. Okay, I'm looking at Friday's assignment.
Okay, I'm getting there.
It's just talking about the volumes of solids of revolution.
Mm-hmm.
Talking about disks.
Yeah, I remember looking over Fridays. Or kind of just glancing at, I should say.
Yeah.
Getting there. I'm getting there. Yeah, it's talking. Was it the one that was talking about slicing or something?
This one's talking about revolving or rotating. I mean, and revolving.
Sheesh, I feel like I'm in the wrong class right now.
There was one earlier this week that was talking about slicing.
Oh, I'm on the wrong one. Okay. Oh yeah. So
day 5 of week 12.
I was on week 13 for a second. Okay, so integrals at volume slicing was on day 4. Riemann sums was day 3, and then day 5 was revolution disks and washers.
Disks, washers, yeah. So for activity A was disks and activity B was washers.
Makes sense. Okay. Did that work pretty well for you? Were you able to get that?
Again? Yeah.
Okay.
Yeah, for the most part, I got them. A couple of them I had a problem with, but then I looked to the answer key, and it made a lot of sense. And I was like, oh, why couldn't I get that before? So
that does look pretty simple. Look, I mean, I'm looking at the answer key right now.
Yeah, they're not too bad.
Gotcha. You're just taking a piece out of the, what do you call it? Find the volume of a solid generated by revolving the area 4 minus x squared. Actually, this really reminds me of engineering where it's like it's not statics, it's the other easy class. What's it called? So we have to make objects with SolidWorks. Do you remember that one?
SolidWorks?
It's not. You use SolidWorks, but I remember you would like revolve things around an axis, and you could cut. You could do a revolve cut, and you could do stuff like that.
Was in 172.
Yeah.
It was just.
Yeah, it's reminding me of that, where basically we're taking the area of it, whereas before the computer just did all that for us.
Right.
Gotcha. Is it 2 minus 2?
No, but I didn't have too many problems, and
okay, well, that's good. At least you didn't have.
Hold on.
I know for me, I probably just need to look more up on it, but I was kind of struggling with those stupid Riemann sums. I was trying to. I don't know. It's all Greek to me.
Yeah.
So I'm just like, what in the world am I looking at? I don't even know what I'm looking at. Let me see if I can pull it up. So I'm pulling up day 3, activity A, if it can pull up for me.
Day 3, activity A. Let me see.
It's trying to make it work. Internet's going slower than it should.
Riemann sums worksheet.
I think, didn't I do that one? I think I did that one. Worksheet. Oh no, this was the one I was actually working on this morning. Yeah. Okay, so I'm kind of confused with this setup, I guess, on these bottom ones here. That's where I'm kind of at, because the n is an unlimited number, right?
N?
Yeah. Doesn't n approach infinity or something? I'm looking at the answer key for it right now. It says 4 minus 0 divided by n. So it equals 4 over n.
Right, so you have your A and your B. So like in this case, up at the top, it tells you that A and B are 0 and 4.
Right, I'm following.
So then you do B minus A over N to find delta X. So 4 minus 0 over N equals delta X.
Okay, I'm following.
And then to find C sub K, you take A plus K.
How do we know it's K?
Well, K is what, like your, so like if you look all the way down at the bottom at the Riemann sum, the solution, it has K equals 1.
Oh yeah. It's kind of handwriting's a little sloppy, but I'm catching it. Yeah, K equals 1.
Right. So that I'm trying to remember what exactly K equals.
How do you even know what K is, though? How do you know it's 1? I see it's 1 on all of these, but
let me see.
C sub. I kept getting confused with this whole C sub K nonsense. I mean, I guess it's not nonsense, but it's been throwing me off.
Right.
It's just like I know how to take an integral. That's what really frustrates me. Like I know how to get the right answer. Like in the exam, there was one that was something with like this, and I'm like, I don't know. I have the right answer. I know the answer, but I don't know this.
Right. Right. Let me see here.
Oh, man, long day. So delta x equals b minus a divided by n, where n is the number of slices. I don't know. And c sub k equals a plus 4 times delta x. Is k like your slope or something?
I think K is the constant.
Is the universal constant always 1?
Yes.
Then why even have it if it's always 1? That's weird. I guess there could be an instance you need it, but huh?
So when you're setting it up,
Yeah.
you're just trying to find the Riemann sum setup. So when you're writing it down, you're gonna have, like, on the first one, it'll be like 0 because that's A, plus K times delta X, and then you solve that. So in the instance of the first one, it would be 4K divided by N.
It has 8k divided by n here. Wait, it says f of c sub k has 2 times 4kn minus 1.
Right. I'm up on C sub K.
Oh, you're on c sub k. Sorry, I was looking at rs. Right, and so basically you plug c sub k into the function for x, right?
Right. So then you plug your c sub k in for x, and then so you would get like 8k over n minus 2.
Does
And
that
then
mean?
you would have
Go ahead.
then you still multiply that by delta x.
That's interesting, actually, because are you looking at the her work on this one?
Yeah, I can. Okay.
Well, I'm just finding it interesting where she has a 2 times 4k over n. That's in parentheses, and it has a minus 1, but she times the whole thing by 2. Did she mess up on that one? That looks like an error to me.
Yeah, I think she messed up on that one.
Okay, so is that 2 is only supposed to be times the 4k over n, right?
Right. Because that's all it's multiplying up top in the function.
Okay, just making sure. It always throws me off when my homework says something incorrect. Okay.
Right. So you really should have the sum, or like the Riemann sum, equals 8k over n minus 1, all multiplied by 4 over n.
Okay.
And then you would distribute your 4 over n in.
Okay.
So you'd get 32k over n squared
Okay.
minus 4 over n.
Okay. And then what do you do with that to solve it? Because this is the setup, right?
So that's the setup. And then once you got it set up, then you will, let me see. So you plug that in.
Because k is if you just plug in the numbers, then it's 32 minus 8
So
over.
really,
Go ahead.
right, really what you would do is you would split the problem first. So you would have the sum of 32k over n squared minus the sum of 8 over n.
Go ahead. That big E thing means the sum of, right?
Right. So you would take the sum of both sides of like the plus sign or the minus sign. And then so like the sum, like an easy example, the sum of 1 over n
Okay.
is 1. Does that make sense? So
sum of 1 over n. Go ahead.
Go for it.
So right now we have the sum of negative 8 over n. Would the answer just be negative 8?
Right now we have the sum of negative 8. Well, actually, you would have the sum of 8 over n because the minus sign goes in front of the sum sign.
Oh, okay. So would that just give you 8 then?
So you'd have
Good.
So that would give you 8.
Okay. And then for the 32k over n squared, we know that k equals 1. Does n also equal 1, or?
Right. So then you can take. All right. So this is what you can do. You can pull the. Let me get back here to it. You can pull the 32 over n squared. You can pull it out in front of the sum sign. So then it would be 32 over n squared multiplied by the sum of k. And we know that the sum of k is 1 because k is equal to 1.
Wait, you can just pull that n squared in front of it, though?
Uh-huh.
What the places? So that would give us 32 over n squared minus 8. Is that right?
I believe so.
Why does the n disappear in one but not the other?
Well, actually, it doesn't. Hold on. That's not the right answer. Because you got to find the sum of k, and the sum of k is not equal to 1. The sum of k... Oh, where is that? Just 1 second. Let me see if I can find this.
You say you don't have much time, so I'll just try to get your help with this, and then unless there's anything I can help with you, I'm not sure that there is right now, but we can just call it good if that's enough for you.
Yeah, I mean, I've been doing pretty good. How did you feel like you did on the test?
As good as I did in the last test. So I mean, honestly, I feel like it was a B minus.
It's not bad.
Yeah, a lot of them I got an A minus. I was actually really surprised, but I don't think I did nearly as well. Looks like my last test I did bad on. I have like a B or something.
But still, if that's what you call bad, like that's not bad at all. That's
That's my exam. That's what I've had for my exams for bad. I know. It might be less than that, but every time I think I fail the exam, I get a B anyway. So for all I know, I did fail. It's just that following that logic, I should have a B because I felt like I was going to fail 3 of those exams already.
Right, that's not bad.
Yeah.
Hold on, let me grab my notes. Because I know there's somewhere where I wrote all these down, and I can't find it now. But
I hate these. I just wish I could stick with my integrals and my derivatives.
Let me find my Riemann sums. Okay. Yes.
That's great. I have error page not found for some notes.
Oh yeah, you gotta. Are you on like the actual MML or?
I'm on Brightspace, whatever that is.
Right. Oh, okay. So, like I logged in, like I went into MML.
Uh-huh.
And I tried to click on the notes section in there because it brings up the same notes.
Uh-huh.
But then I had to close the tab and reopen it up, and it worked.
Okay, I have to do that then. So just
okay. I found it here.
Okay, I'm going back to the page then. All right, I got the page.
Okay, so the sum with the n on top and k equals 1 on bottom of the letter k equals, and I can't remember where this was at, but I wrote it down, so obviously I found it somewhere. But it equals n times n plus 1 all over 2. Does that make sense?
Okay. I don't understand it. All right.
Let me see if I can get this. Can you see that, or is it too blurry?
Oh, let me pull up your screen. I'm looking at the homework right now. Let me see what you got. It's pretty blurry. I've got an MO1. like flat line. I can't see it.
Okay, let me try it this way. So you got the sum of 1
equals n. So wait. Okay, it's like super blurry and it's like the worst thing in the world. But I think there's a 0 on top, right?
No, it's an n on top.
Oh,
and
okay.
a k equals 1 on bottom.
1 equals n.
And then 1 equals n, basically. And then right here you have k equals, the sum of k equals n times n plus 1, 2.
What the places?
And then right here, for the sum of k squared,
Yeah.
n multiplied by n plus 1 multiplied by 2n plus 1 all over 6.
So it looks like you found some kind of formula. I have no idea what kind, but you found a formula.
Right. And then the sum of k cubed
Equals n
is
times n plus 1 over 2, and the whole thing
all squared.
Huh? Sorry, I can't quite see much going on there.
It's all of that squared.
Oh, the whole thing is squared, not cubed. Okay. So n times n plus 1 over 2, where the whole jalopy is squared.
Correct. That's so like when you have, let me turn you back around here. So basically,
All right.
these are my notes from last semester, to be honest.
Gotcha.
And these are the formulas that come with the Riemann sum when you're solving for k. So if you're solving for 1, it equals n.
So for k equals n times n plus 1 or something like that.
N times n plus 1 all divided by 2.
Right. And it's squared, isn't it just, it's that same thing times itself, I think. Or not quite.
N multiplied by n plus 1 multiplied by 2n plus 1. And the whole thing is divided by 6.
Why by 6?
Let me see if I can find a better explanation for you here.
Well, I was just figuring a k times a k would equal k times a k. You know what I'm saying?
Yeah, I mean, like that, it makes sense to me, but for some reason, it's not that way.
I hate when things aren't intuitive.
Let me see if I can provide a better explanation for you.
So it's n squared equals the k. No, the k equals n times n plus 1. N times n plus 1.
Divided by 2.
Divided by 2. 16. And 16n. N plus 1. That gives you 16n squared. Cancel out the bottom. Weird. Weird.
Oh, give me a second here. I'm trying to figure out where I can find this at.
Yeah, let me see if I can pull up the homework if I can make it work. I finished you. I'm glad we finished with you. I'll be glad when we're done with these Riemann sums.
Yeah.
Hot cocoa?
Your answer work.
I kind of want hot cocoa more. Do you want some? Gotta make some in a bit. Welcome to week 13. You ready for the semester to be over, mate?
I am.
I am too. I'm so done right now.
I mean, it's been a good semester. I feel like it's been a long semester.
Huh. I know. I know what you mean. I wish it was. It's been different, that's for sure.
Yeah.
I'm just glad that I have taken this before, because that's really saved me a lot of time, especially when it came to the derivative and integrals. Because I
Right.
could remember all that. It's just these stupid Riemann sums that don't seem to click in my head either.
And if I would not have taken this before, I wouldn't be taking it online. Because I'll be honest, it wasn't explained very well where to find the notes for each section, and the notes are not very good
Oh no, they're terrible.
compared to being in class and the teacher explaining everything. Like, it makes more sense.
Oh no, I absolutely agree. I was complaining to my wife a little bit about not having a tutoring center to have someone explain this, because I just have no idea what's going on half the time, what's going on with these things. Because the derivatives and the integrals are simple enough, they're easy to explain, but when they get these more complex things, I don't think they're well done, especially when the homework is wrong. Oh, that always gets me in trouble, where I spend 15 minutes trying to figure out what I did wrong, and it turns out the homework was wrong. I mean, she said not to spend that much time on it, but how do you know the homework is wrong until you've solved it every other possible way?
Right.
So I don't know. I felt that was kind of a little frustrating, a little bit foolish of a request. But, yeah. So I'm trying to look at the notes. I'm finding limits of finite sums or something like that. If that rings a bell.
I'm sitting here, I'm looking for something, but I cannot find it. Because it's going to be under like Riemann sum.
Mm-hmm.
But you're going to want to look for the sigma notation. And to simplify in sigma notation, it just gives you k squared. It's like if you follow the problem. Are you in the notes right now?
Yeah, I went to my math lab and I'm trying to find it.
So if are you in Riemann sums?
Limit of finite sums, is that the right one? There's Riemann sums is on the next page.
The limits of finite sums is what it says at the top in blue.
Yes.
Okay, so if you scroll down to the bottom of that page, where it says we write this in sigma notation to simplify.
Okay, yeah, k over n times 1 over n.
Right.
To...
So then it kind of just basically goes through everything that we did down until it gets k squared on one side.
They try to get rid of n, basically put on the other side, and then you basically take the sum of k. Interesting. That explains why you're saying the sum of whatever.
So like on the sum for 1 over n
is 1 because 1 goes to n, right?
Well, it's like taking 1 over n and pulling it out front of the sigma sign and leaving a 1 there.
Which goes to n.
The sum of 1 is an n.
And then n over n is 1, so the answer is 1.
So then on the second half of the problem, if you pull the 1 over n cubed out front, you're left with k squared. And then
Right.
if you move down to the next line, it shows that k squared is n multiplied by n plus 1 multiplied by n 2n plus 1 all over 6.
Yeah.
And then you multiply your 1 over n cubed by all of that.
And then they don't simplify all that much there. You could simplify a little bit, but you get like 2n squared plus 3n over 6n squared. Oh, plus 1.
Well, if you're solving for the answer, you really would do that. It would be like 1/3 plus like 1/2
n
over 1 over 2n
plus
1
1
over
6n squared.
squared.
Right.
Right. So then the answer would really just be 1 minus 1/3. And you take off what you had with the n's because you don't know the number n. You don't know what that variable stands for at this point.
So you ignore the n's if you don't know them? Huh.
Right. It's kind of like you ignore them, or you set them like equal to 0.
Yeah. Okay.
And so then you would end up with 1 minus 1/3.
Okay, yeah, I'm following.
1 minus 1/3 is 2/3.
Oh,
right.
I
So
get
then
it.
you get,
Because n goes towards infinity, and if n is on the bottom, it might as well make the whole number 0.
exactly.
Okay, I'm following.
You take the limit of it. You're going to take the limit of it. So then if you end up with any, right, well, like with Riemann sums, you're not going to end up with too many x variables up top.
Mm-hmm.
But if you did, you could take the limit of that.
And that's
whatever. But
right.
But in this case, you're going to end up with a 2/3 as your answer.
Gotcha. Okay. All right. That actually works out. Okay, it works out. I'll give it that. But okay, that actually makes a lot of sense, and that actually helps me out quite a bit.
I have yet to find where I got my nifty notes on what k is.
Yeah, it says, I know it does say at least that the sum of the first n squares, I don't know, but I'm guessing there's some rule for it, but because n times n plus 1. Oh, I know. No. I'll have to think about that one. I'm not sure what's going on there. Because like the n to the k to the third power is n times n plus 1 over 2, and the whole thing is squared, right?
Right.
It's weird. I feel like it's almost like a half step when you just square it instead of cube it, but weird. Something is.
I mean, if you need to, if you need to write these down or something, so you have them to kind of refer back to until you got them memorized.
Yeah,
you're welcome to. I can
probably will. But hey, I really
need to.
Yeah. So, but hey, I really appreciate that. I don't think there's anything I can help you with, and I guess I can let you go here so you can get back to your night. So you said you didn't have too much time anyway, and we've already spent probably 20 minutes anyway.
All right. No, you're good. That works.
All right. Well, I'll let you go, and good luck with your last 2 weeks. I'll see you later on.
All right, amen. You too. Good luck with your last 2 weeks.
Thanks.
Okay. And send me the link as soon as you can.
Right. Yeah, let's do it at 11. I'll hurry on that one.
Yeah. Okay. Thanks.
Bye.
Bye.